These are the volcano notes. The sign is just a warning over top of a volcano about it being dangerous and to be careful around that volcano. Some volcanism terminology. Magma on Earth's surface is called lava. We talked about this when we talked about rocks and minerals. Magma is in the Earth, lava is outside of the Earth. The movement of magma toward or onto the Earth's surface, magma rises because it's less dense, pushing its way into the surface. An event is an opening in the Earth's surface where magma flows through or flows from. And a volcano is the structure formed from a vent and material builds around it. So as the magma comes out, it solidifies, it hardens, and then a volcano eventually is formed from the magma coming out. Some major volcanic zones. Wake up. They're located on divergent and convergent boundaries. We talked about those. Divergent, where you pull apart. Convergent, where the plates come together. And these are places with subduction zones. Think about which boundary that's going to be. You should be saying convergent. It's coming together. At mid-ocean ridges, that's when they pull apart, so that's a divergent boundary. And then at hot spots, when there's that weak place in the crust and the magma pushes its way up and makes islands or supervolcanoes if it's on land. And then here is where all the active volcanoes are. And then the Ring of Fire, you ever heard that song by Johnny Cash? It talks about the burning ring of fire. And that's right around the Pacific plate here. You've got all of these red dots. Those are the volcanoes. So this area around here is called the Ring of Fire because of all the volcanoes. Subduction zones. A subducted plate is subjected to heat and friction and is forced downward, causing it to remelt back into magma. The magma will be forced to the surface and will form volcanic mountains along the continental plate. So where the land is, that land plate, that's the continental plate, will then get the volcanic mountains. And then here's a picture of it. You've got the subducting plate coming down. They're pressing towards each other. So this is a convergent boundary. The oceanic plate is more dense, so it subducts, goes underneath. And then you have the mountains that form on the continental plate or on the land. The Ring of Fire is a result of plates being subducted. So then on that overriding plate, that's where you get all the volcanoes. And there can also be a collision of two oceanic plates forming volcanic island arcs. That's how Japan was formed. And then here's a picture of that. You've got this oceanic plate, that oceanic plate coming together, and it makes that volcanic island arc. And that's, again, the example is Japan. Mid-ocean ridges, those happen at a divergent plate boundary, where magma rises up through the separation in the two plates. It's called a rift. Emerging lava forms new ocean floor. Iceland is an exposed part of a ridge, which is covered with fissures, which are cracks, where magma can come out of. So, again, try to think about this. The mid-ocean ridge, if we look at a map, Iceland is that new crust, that mid-ocean ridge crust exposed above water. And then hot spots. Magma comes to the surface from within a plate. The hot spot stays put, but the plate is in constant motion, forming volcanic islands. So think about the picture that we saw in the last video with that weak spot, and then the magma pops up through and makes some islands. And then this is just a picture with all of the different Hawaiian islands labeled. And then that's a picture from overhead. You can see how the hot spot would be right in the middle, and then as that magma comes up, it spreads out. It's a picture of the Galapagos Islands. And then another picture about the hot spots. As this plate moves, you can see there's that chain of where it's been over top the hot spot, and then you get all these little islands. And then here's some pictures of volcanic eruptions. There are different types of eruptions from volcanoes. You've got violent and explosive eruptions, and then you can have quiet and sort of slow-moving, flowing eruptions. And it depends on the trapped gases and the magma composition, or what the magma is made of. And based on the trapped gases, water vapor and carbon dioxide are trapped in the magma, and at low pressure they can escape quietly when they reach the surface. But at high pressure they escape violently when they reach the surface. So if you think about it, if there's no pressure on you, you're going to be quiet, easygoing. But when you're under a lot of stress, a lot of pressure, you might violently explode. And then there's a picture of a violent eruption. And a couple of interesting words that you get to learn. Pahoho is mafic. Remember, mafic means dark-colored igneous. It's fluid, sort of ropey looking, dark-colored. And here's a picture of the Pahoho lava on the left side, and then there's Ah lava. You can see it looks kind of crumbly, crispy looking. And the or clinkerous lava is, again, brittle and chunky. And you have to write that out on your paper where it says names of materials, and you've got some blanks. You need to go back in and write these two types of lavas and their descriptions. The two general types of lava and magma compositions. We've got mafic, which we've already learned about. Mafic is basaltic. It's got low silica content, low in water vapor, and the carbon dioxide. It is a dark color. Remember, the A's match up. We talked about that on the review guide for rocks and minerals. Mafic is dark colored, and the A's match up. And then felsic. Felsic is lighter colored. Granite, remember when we saw that in the rock lab, is lighter colored. It's high silica content and high in water vapor and carbon dioxide as well. And then here's how the words break down. Magnesium and iron makes the word mafic. And then felsic comes from feldspar and silicon, and that's the lighter colored one. And then different kinds of eruptions. You've got oceanic volcanoes, which produce mafic lava because the crust there is basaltic. So it's dark-colored mafic, dark-colored lava, very thin, flows easily, low gas, and erupts quietly. So not a whole lot of pressure there. And then here's some examples of pillow lava. You saw pictures of these in the How the Earth Was Made video. And that's just lava that comes out from underneath the surface, and then as the magma comes out and solidifies, it pillows into that looking object. And then with continental volcanoes, the lava is going to be a lot more thick, larger amounts of gases with lava that boil out and explosively vent out with solid particles that might fly out. So that shows you an explosive volcano on land. And then the volcanic rock fragments. Pyroclastics are large fragments that are blown from the cone of felsic volcanoes. So we're talking about on land volcanoes. And then here are the different sizes of particles that can come out of a volcano. You can have ash, which is less than 2 millimeters, dust, which is less than 1/4 of a millimeter, and lapilli, which means little stones, less than 64 millimeters. So that's quite a bit bigger than the other two. And then the 3 different types of volcanoes, you do have to write these out. Shield volcanoes, Hotspots will be shield volcanoes, and mafic volcanoes. Anything that has to do with the ocean would be a shield volcano. Cinder cones are felsic. That's what's typically on land. And then composite is just a mixture of the two, a combination between shield and cinder cone. And going in a little bit more detail, a shield volcano covers a wide area, has quiet eruptions, and slow buildup around the vent. So when you look at this picture, it's not very tall at all. It just very slowly increases, and then the vent would be here at the top. It's shaped just like a shield if it was laying down on the ground. And then there's just another picture that shows you the summit. The caldera is another name for the top of the opening. And then, like I said, these are the hotspot type volcanoes where you have magma that slowly comes out and builds up over time. And then there's another real life picture there in Hawaii. And a cinder cone volcano is made up of solid fragments. It has a very steep slope, but it's really high, and it's very explosive. So those are cinder cones. Much more steep than the last one, but not very tall at all. And then here's the real life example in Capulin, New Mexico. And the third type of volcano is a composite. It's formed by alternating explosive and quiet eruptions. It's a developing high volcanic mountains. So these are very tall, but also very broad. So these are very large. And then the example is Mount Shasta in California. Very tall. See how tall it is? This is base level here. But also very broad. The whole thing, and it keeps going out past the picture. Craters versus calderas. A crater is a funnel-shaped pit at the top of a vent, and it's formed when material is blown from the vent during explosions. That's a picture of one. Whereas a caldera is a large basin-shaped depression formed either by explosions or cones collapsing. And then here's an example of a caldera, which is ironically called Crater Lake. And in order to predict the volcanoes, we use a couple of different things. We look at seismographs, which has to do with the earth shaking during earthquakes. And then we study the past history of volcanoes. You can see where one is exploded in the past. It'll probably happen again. The bulging of volcanic slopes. In a minute, I'll show you a whole bunch of pictures of volcanoes right before they exploded, and you can see it's almost like getting a swelled belly. And then the changes in the gases given off. You can measure the amount of sulfur dioxide that is given off, and when that increases, you can tell that it's probably getting ready to blow. And then here are just some pictures. This is actually a home, or I guess a very small shack type building, but it's covered in just lava and ash. And some impacts to the earth. Volcanic ash can block out the sunlight for days or even weeks, and ash just blankets the land. It covers everything. It makes it really hard to grow crops because you don't have any daylight either. And some more impacts. Extremely heated gases can kill anything in its path. If you come in contact with those gases, it can kill you. And those also cause numerous fires, and as well as property damage. So even if maybe a house doesn't get hit with the lava, then it might still get caught on fire by either the gases or just the immense heat. Here's a little diagram that shows you where in the United States we have volcanoes. They're mostly on the west coast because that's over there by that ring of fire, whereas where we live, we don't really have any in Virginia. Let's talk about extraterrestrial volcanism out past Earth. Many planets and moons in the solar system were volcanically active. We have some now, and then there are some that have been in the past. The moon is one. It's covered by basaltic flows, so dark-colored igneous. It's no longer active, but there is evidence of plate tectonic activity in the past. Mars is another example. There are numerous volcanoes and features on Mars. The biggest volcano in the whole solar system is called Olympus Mons, and that is on Mars. Io is one of the moons of Jupiter, and it also shows active volcanoes. And this is a picture of Io. You've got a prominent red oval that surrounds the volcano on the far right. And then there's some pictures from the side. You can see one erupting right there. And then these three most volcanically active states in America. And that's a picture of Mount St. Helens before it erupted. This happened in the 80s. And then right before it got ready to blast or explode. And then you can see this bulge right here showing that it's getting ready to explode. And then the eruption. And then after the eruption, these are little trees that just look like little twigs that have been blown over. And then after, you can see everything's much more flat. There's no more bulge because it just blew out all of these very large pieces of volcanic material. And then you can see the seismologists. They're measuring all the volcanic activity and the earthquakes that were caused by it. And there's some pictures of them monitoring gases. And another picture of before the vent itself, during and after. This whole area here has been blown out by that volcano erupting. And then this is a picture from Pompeii in Italy. When Pompeii exploded, there were people living there, and they didn't really know what was going on at that point in time, and they just sort of hid. And these are people's bodies that have been mummified by ash, just covering them and hardening. And of course, the people had died by that point, though. Now to talk about supervolcanoes. A supervolcano is an eruption ejecting more than 1,000 cubic kilometers of pumice and ash. None have erupted in recorded human history, but it would create a haze of sulfate aerosols that dim sunlight, creating years of a volcanic winter. And hopefully when we get in class, I'll have a little bit of time, we can show you a little bit of a movie about a supervolcano. There is one underneath Yellowstone. We don't know when it will erupt, but it will at some point in the future erupt, being a supervolcano.